Welcome to the DIY Honda Garage channel. The diagnostic trouble codes P0351, P0352, P0353, and P0354 indicate malfunctions related to the ignition coil circuits for cylinders 1 through 4 in the 2015 to 2020 Honda Fit. Each code corresponds to a specific cylinder, signaling a potential issue with the respective ignition coil. The ignition coil plays a crucial role in the ignition process by converting the battery's low voltage to the high voltage needed to ignite the air-fuel mixture in each cylinder. It is located near the engine, mounted on or near the spark plugs. Furthermore, these codes may signal a malfunction in the circuit connecting the ignition coil to the engine control unit, ECU. The powertrain control module, PCM, checks these circuits, and when it detects discrepancies, these DTCs may be triggered, which will affect the vehicle's performance and compliance with emission standards. The ignition coil circuits are central to an effective ignition system in the Honda Fit. The P0351 code points specifically to the first cylinder, while P0352, P0353, and P0354 point to the second, third, and fourth cylinders respectively. Each ignition coil is designed to provide high voltage to the spark plug, enabling combustion within each cylinder. The ignition coil is located near the engine, often directly attached to the spark plugs. The PCM, often referred to in diagnostic contexts, monitors these circuits and initiates codes when it detects faults. These faults may range from internal coil failures to communication issues with the PCM. Understanding their roles is vital for diagnosing and resolving related issues. Various factors could lead to the activation of DTCs P0351 through P0354. One primary cause is faulty ignition coils that no longer function correctly and fail to deliver high voltage to their respective cylinders. Poor electrical connections, which may be caused by wear and tear, corrosion, or loose terminals, can obstruct the necessary current flow. Additionally, open or shorted wires in the ignition coil circuit can lead to malfunctions by preventing signals from reaching the coils or grounding improperly. In some cases, it may even trace back to defects within the PCM itself, which could fail to send or interpret signals accurately. Each of these causes must be investigated, as they can heavily impact engine performance. The symptoms associated with these DTCs can significantly affect the driving experience. Engine misfires are often the most noticeable symptom, leading to a rough-running engine and a choppy experience while driving. This can also result in a noticeable decrease in power output, making acceleration less responsive. Furthermore, these malfunctions can lead to poor fuel economy as engine efficiency declines. Drivers may notice an illuminated check engine light on the dashboard, prompting them to consider consulting a professional. Recognizing these symptoms early is crucial for maintaining vehicle performance and addressing potential long-term issues. To begin troubleshooting for these DTCs, the first step requires turning the vehicle's ignition to the on position without starting the engine. This action powers the vehicle's electronic systems without engaging the engine, allowing for preliminary checks. Next, utilize the Honda Diagnostic System, HDS, to clear any existing DTCs. Clearing these codes will reset the PCM, providing a fresh slate for monitoring. After clearing the codes, start the engine to observe if the issue persists. Finally, recheck for any pending or confirmed DTCs using the HDS. This process helps identify whether the issue is consistent or intermittent, crucial for further diagnosing the problem. After confirming the presence of active DTCs, the next troubleshooting step involves checking the ignition coils themselves. Start by turning the vehicle to the off-lock mode to ensure safety during the process. Then, carefully exchange the ignition coil from the cylinder indicating trouble with one from a cylinder that is functioning properly. This method helps in determining if the issue is with the ignition coil itself or the wiring or PCM. After swapping the coils, start the engine again and check for DTCs using the HDS. If the DTC follows the coil to the new cylinder, it confirms that the ignition coil is faulty and needs to be replaced. If the ignition coils are functioning correctly, the next step is to check for shorted wires, specifically focusing on the IG coil RLY out and IG1 IGN line. Again, turn the vehicle to the off lock mode for safety. In this step, locate and examine the fuse number B8, which is a 15 amp fuse located in the underhood fuse relay box. If this fuse is burnt or damaged, it indicates a potential short circuit in the wiring. Should the fuse be found faulty, repair the short in the IG coil RLY out or IG1 IGN wire that connects the ignition coils and replace the damaged B8 fuse to ensure power is restored properly. Once the fuse is confirmed to be operational, the next step involves checking the ignition coil relay located in the underhood fuse relay box. Begin by removing the ignition coil relay to assess its functionality. This component plays a crucial role in facilitating power to the ignition coils from the main power source. Testing the relay will help determine if it is conducting electricity properly when needed, following all required diagnostics per the manufacturer's guidelines. If it is found to be faulty or does not operate as required, it must be replaced to restore proper operation to the ignition system. Proper functioning of this relay is crucial to ensure the ignition coils receive the necessary power to operate effectively. Once the ignition relay has been reinstalled, it is critical to proceed with an open wire check, focusing on the IG coil RLY out and IG1 IGN line. Start this process by disconnecting the connector to the ignition coil of the cylinder identified as problematic. Activate the vehicle to the on mode. During this stage, measure the voltage between the designated test points. Test point 1 is from the ignition coil 3P connector, and test point 2 is the body ground. This check will determine whether there is battery voltage present. If voltage is confirmed, it indicates that the wiring leading to the ignition coil is intact. Alternatively, if no voltage is detected, this suggests that an open circuit exists in the wiring that requires repair to restore electrical flow. Following the voltage check, if battery voltage is confirmed, the next step involves checking for continuity specifically on the PG1 wire. Turn the vehicle back to the off lock mode to prepare for this diagnostic step. With the ignition coil 3P connector disconnected, check continuity between test points 1 and 2, ensuring that the circuit is complete from the ignition coil to the ground. This is crucial as continuity indicates that no breaks exist in the circuit. If continuity is not present, it implies an open wire situation between the ignition coil and point G101. In such instances, repairs must be made to restore proper electrical connectivity. To further diagnose the situation, the 7th step entails checking for shorted wires within the ignition lines. Start by jumping the SCS line using the HDS, which essentially simulates a short circuit condition for testing. Next, disconnect the PCM connector B51P to limit the test to control lines associated with the problematic ignition coil. Check for continuity between the body ground and the corresponding terminals of the problematic ignition coil in the PCM. When measuring this continuity, it confirms whether the circuit is functioning as anticipated and whether any shorts exist. If continuity exists, it indicates that the wire is intact and potentially eliminates it from being the source of the problem. However, if continuity isn't noted, This suggests a short exists in the wiring, which will need to be repaired. The final step in this diagnostic process focuses on ensuring there is no open wire check within the IGN lines connected to the ignition coil. To execute this, check for continuity between the specific terminal of the ignition coil 3P connector number 3 and the corresponding terminal in the PCM connector for the troubled ignition coil. This test will generally be performed while the vehicle is still in the off lock mode. If continuity is found, this indicates that the IGN lines are functioning correctly. However, if the continuity test fails, it requires attention and repair to rectify any open wires between the PCM and the ignition coil. It's important to consider updating the PCM if it hasn't been done already, as advancements in software can often fix unresolved issues leading to trouble codes. Alternatively, if necessary, substituting with a known good PCM can effectively validate this step in troubleshooting. Once all necessary repairs and checks have been performed, it's crucial to verify the work done. Begin by clearing any DTCs from the HDS to reset the system. Afterward, take the vehicle for a test drive under various driving conditions to ensure that performance has improved and that there are no recurring issues. Pay attention for symptoms like misfires or illumination of the check engine light. If no DTCs reappear after the test drive, it's a good indication that the issue has been resolved successfully. Detailed documentation of each step performed gives insight into the troubleshooting process and can aid any future maintenance needs. To prevent future occurrences of DTCs related to ignition coil malfunctions, establishing a routine preventive maintenance schedule is essential. Regular inspections of the ignition system, which includes checking the integrity of wiring, fuses, and ignition coils, can help identify potential issues before they escalate. Monitoring the system through regular diagnostics allows early detection of DTCs, leading to quicker and less costly repairs. Additionally, components on the verge of failure should be replaced proactively to maintain system reliability. This proactive approach to vehicle maintenance can extend the lifespan of critical parts, ensure optimum engine performance, and uphold fuel efficiency. In conclusion, understanding the roles of the ignition system components is vital in diagnosing DTCs P0351 through P0354 effectively. Each component plays a specific role in ensuring proper performance and efficiency of the engine, and recognizing symptoms early can lead to more efficient repairs. Following a systematic troubleshooting approach is essential, starting from basic checks and moving to more complicated diagnostics ensures thorough coverage of potential issues. Utilizing tools like the HDS for accurate diagnostics streamlines the repair process. By adhering to preventive maintenance practices, you can avoid future complications related to ignition coil circuits, maintaining the vehicle's overall health and performance. Please like and subscribe to the channel. See you next time.